Good day, class. This is our fourth lesson. In the previous lesson, we learned about the formation of ion. So there are two types of ion, and you had a worksheet to complete that drawing diagram for the formation of ion, positive ion and negative ion. Okay. In today's lesson, we want to extend that idea a little bit more deeper. So from drawing those ions, we want to see how those ions are attracted to each other to form an ionic compound. Okay, so I just like to show today's PowerPoint. We have one PowerPoint, or we have two actually. One is forming of the ionic compound, and the other one would be some properties of them. Okay, we also have two worksheets that will be helpful for you. Okay, this is one of them. And then this is the other one. Okay, and of course I like to, okay, oh, this is the one that given last week. So we like to revise everything. Okay, so before we begin into the lesson, let me review with you about the assignment that was given to you last week. Was you able to do that assignment or not? It's lesson 3. So in the previous assignment, you were given this worksheet to draw the ions. Okay, so you had a few of them. You draw positive ion, negative ion. So I'm gonna just take maybe one of them and discuss with you. Okay, I'm gonna use, for example, aluminium here. So when we look at periodic table for the aluminium, you know the mass number is 13. Okay, the atomic number is 13. So it means it has 13 proton. Therefore, it also means it has 13 electrons. So we know the arrangement should be 2, 8, 3. Okay. So if you want to draw, you need to draw the first shell, second shell, and the third shell. All right. And you're going to put the electron. There's 2, 1, 2. And there's 8 here. 1, 2, 3, 4, 5, 6, 7, and 8. And you know this, it has 3. 1, 2, 3. Now, when it becomes ion, it will donate the 3 electron that is in the outer shell here. So what is going to remain is only the first 2 shells. 1, the first shell, and 2. Am I right? So the other 3 electron is donated. So we're going to draw this 2 only, the inside here, and we're going to draw the 8 here. Okay, and because this is an ion, we need to put a bracket. It's just a concept. Now, how many have donated? Donated 3. If you donate 3, you become 3 plus. Okay. So guys, this is for a positive ion. Now, let us see one example of negative ion, the one that you all did last week. Okay. Let's say we talk about oxygen. Okay, example, oxygen. So same thing. Oxygen, we know the number is 8. So it means it have 2 and 6. 2 and 6. So it have first orbital with 2 electron, second orbital with 6 electron. All right, so you're going to draw all the electron. 2, 1, 2, 3, 4, 5, and 6. So you know it is not stable. Therefore, it will take another 2 electrons. So we're going to draw again the same first shell and the second shell. And this time, we want to draw all the 8 electron. 1, 2, 1 and 2, 1 and 2, 1 and 2, 1 and 2. And because it has taken 2 electron, it is going to be 2 minus. Okay, so guys, this is the activity for the last week assignment. Okay, I hope you were able to do that and complete it. Okay, today we want to see formation of ionic compound. After you form the ion, how you can form the bonding. So this is just continuing with the whatever you have learned before. It's not something new. So you see, first you form positive ion. Second, you form negative ion. After you form this negative ion, you form the bonding, because you must remember the positive and negative always are attracted. Just that for the learning purposes, we put it separate for you. We teach you positive first, then negative ion first. Okay, but you must know it is formed together simultaneously. So how it form positive ion? So again, this is a form of repetition for you. And how it form negative ion? Same thing. You receive the electron. So once you have a positive ion and a negative ion, what will happen? You're going to be attracted to each other. What type of attraction is known as electrostatic attraction? Okay, then they form the bonding. So an example is we have here sodium and chloride, and because we want to show the concept that there is an electron transfer, we like to use a method called dot and cross. So for example, if you use a dot for a positive ion, you're going to use a cross for negative ion, or vice versa. So in this case, you can see this is sodium. It had 2, 8, and 1. So it will donate this 1 electron to the chlorine, because chlorine having 2, 8, and 7 is not stable. So now when it donate 1, it becomes a positive ion over here. And over here, because it receive 1 electron, can you see this small blue dot? It become a negative ion. Then we draw this inside each other to show that they are attracted. Okay. So we can see some other example as well. The dot represents the electron of one atom, while crosses represent the electron of another atom. So it doesn't matter which one you want to use. Okay. So this is the idea that we use. For example, this is magnesium chloride. Same concept. Magnesium having 2. Each one don't need 1. So magnesium become free from anything excess, so it become 2 plus, donated 2. Each of these chloride take 1, and we draw chlorine this equally balanced. Okay. Each magnesium loses 2 electron, each chlorine gain 1 electron. This is electrostatic attraction between magnesium ion and chloride ion. Okay, so guys, that's the idea for today's activity. Okay, and to do that, I have one worksheet for you here, actually 2 worksheets, It's lesson 5, we'll show you lesson 4. So this is a lesson 4, same. How to form positive ion, how to form negative ion, how formation between the positive and the negative. So this is worksheet number 4 for today's lesson number 4. So with that concept, you need to draw for lithium fluoride, magnesium oxide, calcium sulfide, aluminum phosphate. sodium fluoride. After following that, you have another worksheet that is, this is similar. This is lesson 5, this is similar, just a different compound. Okay. The example from the lesson number 3 and number 4 just now, you should be able to do this. Okay. Now, we may ask, what is the properties of this ionic compound? Is that different? So let us see, what is the differences between them? Or before that, anybody have any idea? Anybody like to share from our class? Susan, you like to share? Anna? Okay, you like to share? Clement, Joy? Okay, good. So you have some ideas, very good. Okay, guys, now, this is talking about the physical properties of ionic compound. First, they have their volatility. They have a high melting point and boiling point, means they are not volatile. Most of the time, they are solid. Solubility, they are usually soluble in water, but not in organic solvent. Electrical conductivity, they can conduct electricity in molten and aqueous state. Molten means you heat them, aqueous means you add up or dissolve them inside water. Okay, so why melting and boiling point? You see, they have a very lattice ionic compound, strong ionic bond, large amount of energy is needed to overcome this strong bond, extremely strong, they're solid, high melting point and high boiling point. Okay, solubility, they are usually soluble in water because they can become ions inside water, am I right? So you can prove that, for example, when you have sodium chloride, you dissolve and you fix a battery and you fix a bulb, the bulb will light up. It shows that electricity can pass through the aqueous sodium chloride. Solid, no light up. However, if the solid you can heat up, it can light up, means the liquid form of that compound can, but you have to heat up. So ionic compound do not conduct electricity in the solid state because they are no free moving ion. But once it is melted or dissolved inside water, it can conduct electricity because they are free to move in the molten state or in the aqueous state. Okay, so that's the idea. So guys, this is our learning today. We have 2 worksheets for you to complete. I just like that you try to do it because the next lesson we are going to into the covalent compound. And if you have any problem, just let me know. Okay, so guys, that's all for today. See you again.